In this lesson, we are going to look at solving problems involving partial variation. As a consequence of this lesson, you are going to distinguish between joint variation and partial variation. Joint variation is what we're looking at in the previous lesson. So how can we describe or how can we define partial variation? So partial variation is a relationship that can be plotted on a graph, and the result of this graph is a straight line that does not pass through the origin. So any relationship between two variables that results in a straight line that does not pass through the origin but obviously will cut the y-axis somewhere is what we're calling a partial variation. So this can be represented graphically like I'm trying to show you right now, not with red, let's pick black. Okay, so graphically, okay, mind my axis. They're not that straight, but anyway, this is a sketch. So what we are saying is that this straight line will cut the y-axis. It will not pass through the origin, but any other place. Such a relationship between two variables is what we're calling a partial variation, and the equation that is represented by this variation is y is equal to mx plus b. So in terms of notation, this relationship between y and x can be expressed as an equation, and this equation will be y is equal to mx plus b. The m part is the variable part, and this same m part is the gradient of the straight line that I was showing you previously. Then the b part is the fixed part, and it will be the y-intercept. To be the y-intercept of that graph. So if we want to represent a partial variation in equation form, we write it as y is equal to mx plus b. The m is the gradient of the line. Then the b part is a fixed part, which is also the y-intercept part. Let's look at an example. Oh, wow. Okay. So in this example, we have been given a graph. There's a graph alongside, and in this graph, basically, we are talking about a relationship that is exhibited between cost and time. We are renting a room. So when we're renting a room, we have been given the cost of renting a room in relation to the time that you take in months to be in that room. So what are they asking us to do? So part A is saying determine the equation for the situation in the form y is equal to mx plus b. This is the general part. We need to come up with an equation that will help us find an equation in this situation. So the first thing we need to do is we need to find what m and b is. So for the m part, like I said, it is the gradient of this straight line that you're seeing here. So we need to pick 2 points on the line. So I'm going to pick this point and this point. So when I pick those 2 points, you find that the coordinates is there. The coordinates will be 2, 4,000. That is the first one, and then the other one will be 4, 6,000. So 4 is the x coordinate, then 6,000 is the y coordinate. So we have the ingredients now. So we're going to say, no, yellow won't be seen. Come on, it's blue. So we'll give, we'll assign x1 to this one, y1 to this other, then x2 to this coordinate, then y subscript 2 to the other one. So for us to find the gradient, we know that the formula for that is y subscript 2 minus y1 over x2 minus x1. That is how we find the gradient. This is the formula. So looking at my assignments, y subscript 2 is 6,000 minus 4,000 over 4 minus 2. So these assignments is what I am trying to put up there. So when we subtract this, we're going to have a 2,000 over 2. So m will be 1,000. Am I running out of space? No, I don't think so. Then B is the y-intercept form. The y-intercept form is where the straight line cuts the y-axis. So this is our y-axis. I don't know if you're seeing that. Let me change the color. Okay, so this is our y-axis, then this is our x-axis. So where this line cuts the y-axis, the point at which it cuts the y-axis, the y-coordinate at which it cuts the y-axis is our b. So b will be equal to 2,000. So what is, I'll write the solution right here on top, right here. I hope you're going to see that. So the solution for A will be y will be equal to m is 1,000 x plus b is 2,000. So this right here is our solution for A. Okay, let me rub out all this. Let me rub out all this, so that we make room for part B. Part B. Come on, Mr. Rubber. Mr. Rubber. Eraser. Okay, so part B. Very exciting. Part B. What will it cost to rent a room for 20 months? So you already have a model. You have created a model here for predicting the months even beyond what is on this what's this graph? Yes. So what will happen now is that we are not going to say y. Let's use the variables that have been given in this question. So y is cost, and then x is time in months. So this is like months here. We have months plus 2,000, right? So what we need to now find is the cost when we have been staying in this room for 20 months. So all we need to do is substitute the 20 where there is a month there. So we'll have 1,000 multiplied by 20 plus 2,000. So we multiply 1,000 by 20. We're using BODMAS. Don't ask, no, what? Yes, we start with multiplication. So 1,000 by 20 will give us 20. Is it 20,000? Yes, we'll have 20,000 plus 2,000. And the cost will be 22,000 kwacha for staying in this room for 20 months. I hope we have learned one or two things from this lesson. I hope I haven't rushed things or haven't been too slow. Anyways, you can leave a comment, you can subscribe, you can like and share the video, or you can rewind, you pause, you can put the video at ×2 if I'm too slow, or otherwise. We'll meet in the